I want to go over the steps for model building. And this is one of the things that's common to all of our multivariate techniques, the steps we're going to go through. We're going to talk about the setup, developing a testing and analysis plan, evaluating assumptions, evaluating the whole model for global fit, and variable, interpreting particular relationships, and then validating the whole model. Obviously, the particulars of this step-by-step plan will change according to the multivariate technique that we use, but overall, this is kind of how you do it each time. And if we can answer these questions each time about how we do a particular technique, then we'll be really familiar with the material. So the first step is defining the model, the measures, and the multivariate techniques. So the first place is the model has to come from your brain, right? So here we're using and previous research and really defining what the concepts and constructs are. This isn't about the measures. This is about what the constructs of interest are. What are we trying to predict, and what do we think is going to predict it, right? So as base level, job satisfaction, predicting job performance. We want to think about what predicts what. Honestly, I highly recommend always drawing a diagram so you know exactly what you're predicting. What is predicting what? What does the model look like? What's the direction? What's the magnitude of that prediction? What doesn't predict what? Classic example here, we all think job satisfaction predicts job performance. The study showed that the relationship actually works the other way. Job performance predicts job satisfaction. Now, over time, when we have good job satisfaction, yeah, that also begets job performance. It's actually more of a reciprocal relationship. But don't just assume that what you think is the direction that's involved, but you have to think through those things. Another example of cognitive ability predicting performance. Classic prediction in IO psychology. Cognitive ability predicts performance. But maybe it predicts task performance differently than it predicts conceptual performance, right? Or contextual performance. And contextual performance is things that we do outside of the task. Pro-social behaviors, counterproductive work behaviors, organizational citizenship behaviors, helping each other out in the workplace. Those all go into job performance overall, but maybe they're different from task performance, and maybe cognitive ability predicts those things differently. Now, at this point, we're just talking about large concepts. We haven't even started talking about the measures yet, right? How are we measuring these things? Supervisor ratings, performance metrics for task performance, peer ratings. Depending on what measure we choose to use, we may get different outcomes. So we have to carefully choose what our measures are going to be. We want to pay particular attention to using categorical versus continuous variables. That's going to have an effect on the type of multivariate analysis we do. So for instance, are we looking at old versus young, or are we looking at age as a continuous variable? Really choose your measures wisely, because they are really going to affect your outcomes. And then finally, we're going to choose our multivariate technique. You can use, HARE has a pretty good flow chart that I've put onto Blackboard that you can follow about how we choose multivariate techniques. And over the course of the semester, obviously, we'll talk about why some are more valuable and useful than others in certain situations. Then we're going to develop an analysis plan. Once you've developed your analysis plan, so you've chosen a multivariate technique, now we're talking about how are we going to go about collecting data? How are we going to analyze that data? When are we going to be able to take these measures? What's the sample size we're going to need? What's the power that we're going to get with that sample size? Are we going to be able to detect things? Is it going to be powerful enough? We may have to revisit our measures and study plans in order to make sure that, because our particular analysis requires a different sort of study plan. So we really have to think through the analysis plan and don't just kind of wing it. Once we've collected the data, our next step is going to be to evaluate our assumptions. We want to make sure, one, that our conceptual assumptions are met and that our statistical assumptions are met. We're going to talk throughout the semester about the assumptions that we make when we do our multivariate techniques, things about data normality, things about relationship normality. Now, some tests are more robust against those assumptions. Some are very fragile against those assumptions, and so we really need to pay attention to that. So once we've evaluated the assumptions, our next step is to estimate the overall fit, right? So we want to estimate the multivariate model as a whole. So we're not looking at particular relationships at this point. We're looking at, does the model fit overall? So even in a bivariate regression, this is not yet looking at the regression coefficient. This is, does the model fit the data? Does it explain overall the data well? We're going to get into this, but this is a global fit decision. We want to determine if the model is the right model before we start looking at relationships. right? It kind of doesn't, if we're trying to fit a square peg in a round hole, it kind of doesn't matter what the sides of the square look like and the sides of the square peg look like and how those relationships among the faces, because it just doesn't fit the hole that we're trying to fit. So it kind of doesn't matter. So the first step is when we're doing our analysis to estimate the overall model fit, the global fit. We're going to use various techniques, and it all changes according to the technique that we use. Things we've used before, R squared, F, chi-squared. These are actually all examples of model fit statistics that we're going to use throughout the semester. If the model doesn't fit the data at a global level, then interpretations of the data and inferences we make based on those interpretations don't matter, and we may actually be wrong. Key point here is that you may have to re-specify the model to get it to fit. And as soon as you decide to re-specify a model, we're doing exploratory analysis. Now we're hypothesizing after results are known, or harking, and there's a lot of danger there. So be aware that that's what you're doing, but be aware that the first thing we have to do is check our global fit. Once our global fit is okay, then we interpret the particular fit, the local fit, all the relationships. Now we can look at how particular variables within our model are related to each other. And we can, now these are estimates, they're not necessarily exact, they're going to be confidence intervals around them. And we're going to, but these estimates are the ones that we use to actually make our inferences about our hypotheses. And again, we may have to re-specify, right? So we may have a model that fits globally overall, but we may have no relationship between two variables that we thought there would be. And so maybe we drop that out and reassess the fit. Again, that's exploratory, and we want to be careful with that, but there might be some re-specification at this point as well. And finally, once we've established the local fit, those local relationships, we're going to validate the final model. Particularly if we have re-specified in any way, we need to validate the final model against a new sample. Otherwise, we're capitalizing on chance, and we're just finding things that are particular to our sample. If we think that our findings are the correct ones, they should predict the same outcomes in a different sample. Now, sometimes that means going and getting new data. Sometimes that means if we have a large enough data set, we might split the sample in half and do our exploratory analysis on one side, make predictions based on that, and then see if they get borne out in the second half of the sample that we haven't tested yet. This is a key step. If we've gone through some re-specification process, we really do need to validate the final version of our model. So altogether, this gives us some steps that we're going to use each week, and each time we do a different a different multivariate analysis technique, we're going to talk about how we estimate the global fit, how we estimate the local fit, and how we interpret those, what the assumptions are, and what the data analysis plans are that are appropriate for those particular ones. So those are the step-by-step. Again, you can find this in the Hair It All reading, but I wanted to make sure we went over it here.